Your organization is building and updating business-critical web applications faster than ever. And with so much pressure to move fast, you may find yourself making trade-offs between innovation and security. Now you can build fast without sacrificing security with Invicti, the zero-noise application security platform that helps your dev, sec, and ops teams work together to secure every website, web app, and API. With unparalleled accuracy, coverage, and automation, Invicti scales like no other AppSec solution. Invicti, AppSec with zero noise. Visit securityweekly.com/Invicti. Passbolt is a free and open source password manager that allows your team to store, organize, and share passwords securely. Passbolt is privacy first and highly versatile. It can be installed on-prem behind your firewall, used in a secure cloud, or deployed as a cloud-native application. You can check out the source code on GitHub, extend it with the REST API, integrate it with the CLI or SDKs, and even contribute. Get started with Passbolt for free now. Check it out at securityweekly.com/Passbolt. Welcome back to Application Security Weekly. We just talked with Adrian Sanabria about myths and lies in InfoSec, why they're harmful, and how we can start correcting them. I'm your host, Mike Shima. I'm here with John Kinsella and the Ace of Spades, and it's just about time for the news. But first, an announcement. Do you have a specific guest or topic that you want us to cover on one of the shows? Submit your suggestions at securityweekly.com/guests. We review them monthly, and we'll reach out to you once reviewed. And now, after I have an article that I'm itching to get to, John, because it ties into our discussion, our fun discussion with Adrian about myths and lies. But before we do that, there's a bunch of other articles, and we also want to welcome you back. And I'm going to welcome you back with another question from our AP I Don't Know. These are the questions that we want to hear more from our audience. Please send them in, drop them in Discord or elsewhere. But this is a real quick, short one, I think. Do we need a bug bounty program? There's the answer right there.
That's, it's, I'm just thinking like, okay, imagine if I was, I don't know, CISO of a 400 or 500 person company, and an exec came to me and asked that question. Hey, I've been hearing about bug bounties. Should we have one? I lean towards yes. I've advised a few startups over the last few years to add bug bounty programs. So I'm in favor of them. I guess the next question then comes down to budgetary and things like that. But I think in the most minimal sense, modern day bug bounty is sort of equivalent of a security contact from 10 years ago. So yes. What's your answer?
Yeah, and
did I pass?
These are open questions. We neither pass nor fail. That's for our listeners to decide. We'll see. Let us know. I think I would add to what your answer and say, because you started with kind of like a 500 person size company. So I think you're starting to talk about maybe either the size and budget, but as well as the maturity of the development team. Because if you launch one too early, you're going to end up only ever doing bug ops, meaning here's a bug, got to fix it. Here's another bug, got to fix it. Or you're just basically financing a whole bunch of random people on the internet to run SQL map, to run AMAP, to run a whole bunch of different scanners against your systems that you should have run yourself. So I would say, yes, you need a bug bounty program. Initially, you just need a vuln disclosure, the security contact that you mentioned. After you've done some basic scanning, some basic health of your code, and you have a process for improving code that can involve like revisiting designs, revisiting architectures, or getting rid of a bug class, then start thinking about how to budget for a bug bounty. That would be my answer.
I think that comes back to what I was mentioning around the budget. And like I haven't walked someone into HackerOne or any of the systems anytime recently, but it'd be really cool if they had sort of the ability to, when a new company comes in, they're a new organization, that they start you off with really either ask you those questions, when was the last time you had that scan done, or start with the numbers being really low. Okay, if someone wants to SQL map you and get $5, okay, cool, that's great. And then once all those type of things are taken care of, then maybe I understand it's not just $5, it's the time of the resource in the company. But
of course, yeah.
I wonder if that would work. But
yeah, and Katie Musuris talks a lot about this. So if you want another answer, just go look to see what she talks about on this topic. But Mr. Kinsella, I asked you a question, but now I want to throw over to, I think, a favorite topic of yours. We haven't talked about aviation in a while. We talked about in the past some bugs in like Boeing, and there was some 3D printing or virtualized modeling that you were talking about. But here is a 747 flight. Tell us more. What happened here?
Yeah, I was actually watching this live last week when it happened. So the Boeing 747, Queen of the Skies, the last plane, the last one period was manufactured and left from Plain Field here in Everett, Washington, last week, off to be used for cargo. But as they were leaving, they decided in Eastern Washington to map out or draw a crown. And it's funny. Just you got me going on this one, man. We'll go be here all day. I actually did the math on it. That crown cost probably about $30,000 for them to map out. It's pretty huge. It covers, I don't know. It's got to be about 100 miles. But yeah, so they did a little crown with 747 as a tribute back to. You can actually see this. We've got a screenshot in this article. You can go out to FlightAware or whatever else and actually see it and watch it go through. But yeah, so that was the start of it. And I think you wanted to bring this back to talking about application security or maybe source code in general.
Indeed. So
I'll let you go first because there's a few ways we can go.
Okay. Yeah. So it's fun to talk about these topics, and yes, I do like to draw them back for a reason. We're talking about them because drawing this with a flight plan is maybe the aviation equivalent of some fun ASCII art. And ASCII art, you can see that in SQL Map logo, for example. I mentioned that as our tool of the week last episode, and I linked to the Cult of the Dead Cow. So here is an old school, if you will, a 90s era hacking group, and they would use a lot of ASCII art in their write-ups, and this was before the age of memes, if you will. And so I'll set it up there and then come to some other applied things. But that's the art side of things. But there's also Easter eggs and other stuff we could talk about here, John. I'm curious where your mind went.
I'm remembering also Frack had those too, I believe, in there.
Indeed, yes.
But when I first saw you mention this, the one that popped in my mind is an ASCII art, but Motorola? Yeah, the guys, SGI, the guys doing the MIPS chips back in when Jurassic Park came out. One of the MIPS CPUs actually has a little dinosaur in the silkscreen on the chip, so I thought that was pretty cute too.
That is amazing. And so there is this is the fun part. We see this in the people build software, right? And so people wrote Frack. I've referenced those articles a bit, and they just want to look, rather than at, all of this 7-bit ASCII code all the time, they want to see something interesting. However, there is an angle that turns into Easter eggs, meaning there's some secret code within Microsoft Excel, for example, that might be a level of doom, or other things that starts to straddle the line of maybe there is some security concerns here. I think in the sense of why does this, one, just there's more complexity, there's a growth of attack surface, and just how approved was this code that got into something that into Excel or into another business code. So that's where it's fun to talk about, fun to think about, but I don't know necessarily that we want to see Easter eggs all the time in all of our software.
No, I've said before, I think on here, I used to put in comments, not the code, but I'd write my source code comments in iambic pentameter sometime when I get bored.
I love it.
I was just trying to I wanted to see if we could hit ChatGPT and see if it could give me ASCII art, but it's too busy right now. So try that later, audience.
But we could ask ChatGPT to help us with some of the code that you've been writing, John. Rather than iambic pentameter for your commits, it might help with something else.
Yes. And it's funny, I wasn't even leading that way, but apparently this ChatGPT thing has been on our minds quite a lot recently. A tool I found in the last week or so is in one of my tabs here somewhere. I don't even see it. It's Commit GPT. So a big pet peeve of mine, as I'm sure we've talked about here before, is bad or just completely missing git commit messages. I think in some ways the commit message can be more important than the source code which someone has modified, depending on what that is. But I always say that 3 o'clock in the morning, you're going back through Git logs. Someone changed something. Why? What's going on, right? So that's the reason behind it. But anyways, some fine folks went ahead and hooked the Git thing up to the Chat GPT thing. And now when you do a Git commit with this particular little module, which we have a link for, it'll look through the changes, summarize it, and actually create or give you the potential Git commit message. As with anything coming out of ChatGPT, you still need to review it and look at it. And as we're starting to see, some of the larger software companies are now saying, please don't send our source code to ChatGPT because we don't know where it's going. So use with those little caveats, but interesting to see that they're trying to do that.
Interesting to see. And for me, we could actually, we'll have to make a note about the Git comments, Git commit comments, or maybe code comments over time. Because for me, most of the time I think of Git commits as being helpful of why this code changed, or maybe some decisions behind it rather than just what changed. So if the GPT is just saying, we renamed the variable from A to I because we like the letter I, not very helpful. That's whether it's a human or GPT giving that information, not a great Git commit message. So go ahead.
Man, they got me thinking. I'll agree with you on that. Yeah, that's frequently not very helpful. We want to hear the other neurons firing. But at the same time, if someone intended to change just one line of code and suddenly there's like 50 other changes in there, that could be a tell. But now the human would hopefully recognize that if they check the Git diff. Would ChatGPT just, so it actually might be worse now that I think about it. So
that's interesting. Yeah, we'll have to experiment with that. Some others. Let's get some different neurons of those of yours firing, John. Last week, Akira and I were talking again about memory safety, and secure code and coding language and programming is a common theme we've been touching on, especially this year. I'm going to start with two different flaws. One in OpenSSH. So OpenSSH 9.2 fixed a double free that was remotely exploitable. It was a pre-auth. So double free pre-auth are kind of those dangerous words. You don't want to see those. Those are not mythological words. Those are legendary words about vulns that could be nasty, especially in OpenSSH. But what was interesting about this, I think, is that OpenSSH written in C. So here is our C is bad language statement of the day. But it's, they were making the claim that it looks like it is, the process is sandboxed. It drops privileges, and so it's probably not exploitable, or if it were exploitable, it may just be equivalent to a DOS rather than a full-on RCE. And I wanted to highlight that in the sense of, yes, we can have memory safety issues, but we don't just have code that is a monolithic about a single type of attack. And I linked to in the show notes some different sandboxing code if you really want to dive into some of the C on Mac OS, on Linux, and how using setconf. So it's pretty simple, straightforward, pretty cool. But I thought that was just that was the angle I wanted to take this, in the sense of, yes, another memory safety issue, a double free in C code, but maybe there's something we could talk different about it. I'm not sure.
Yeah.
Does that sound convincing, John? You said you agreed with me once. I'm trying to go for two.
You're convincing me. I'm not sure if we're going to convince. Excuse me. I'm still getting over this stupid thing. So I thought, let's see, I'm going to reel back on that one.
Sure.
What was interesting about the OpenSSH thing itself, so this was discovered by Qualys. The team over there is killing as usual. What was interesting, this was discovered through manual code review. They had a post about this on OSS Security, the mailing list. But they actually, when they first discovered this and reported it to OpenSSH, they didn't realize how bad it was till the other guys started looking at it and going, oh, that's actually a double free. Still fairly hard to leverage this into an exploit, but it's a pretty gnarly little one. Small code change to fix it, but yeah. So going forward with that, I'm going to tag on another article I've got in there from our friends over at the people at the C++ working groups. This time the direction group. So this is where do they intend to take C++ in the next probably 18, 24 months. Again, written by Bjarne Strostrup. I always mispronounce his name. My apologies. And this now, instead of being a 2-page PDF explaining why safety in C++ is just fine, is a 10-page PDF explaining how safety in C++ is just fine. It's interesting. It's as I was looking at this, there's a little bit of, I didn't put the links in, but there's a little bit of teeth gnashing happening on the Twitters over some of this type of stuff of like, so the point which these guys are trying to say is Rust is great at what it does. but that has its own domain versus C++ is used for a lot more things. And sometimes people don't want the safety of security, the overhead of security, which I totally get. And one of the interesting things about that there is, okay, we talk a lot in this show, at least from my point of view, interesting, is, okay, but can we be secure by default? Like in Rust and some other language out there, you can actually disable the security when you want to say, hey, I want to do something stupid here, and then go, do what you need for high performance. But it feels like these guys, they're opening up a little bit and saying, okay, let's talk and see if there's something we want to change the direction of C++. But like one example of what they want to do is they would rather, instead of putting the security into the language, to have static analysis tools or something run ahead of time, which will actually go through and make everything just perfectly fine. And I think we know by now that that's not really how it works. It sounds nice, and that's given us a lot of improvements over the last 20, 30 years, but still that you need something in the actual language itself, I think is the common thought, or at least it is from my little neck of the woods and bubble. But so that was that one. I don't know, was there more things we wanted to address?
No, I think let's skip over to an article I pulled in that is, I think, a great segue that you set up right there. And I'm a fan of LLVM and its sanitizers. Let's move a lot of the security into the compiler for the language. Here is an article about what makes a programming language secure. And one of the things I wanted to highlight too, before we get into the meat of the what is that as a tie-in to our discussion with Adrian about myths, and Adrian made a point about, if you're going to share statistics or you're going to share a survey, give some data, give some, what did you do? Give some context about what you're talking about. And a quote from this article is talking about when you see a company that says, our analysis finds that these languages are more error prone. Probably, unless they're providing the type of information that Adrian was saying, give us so we can understand what you mean by this. This company is probably saying our analysis is better at finding errors in these languages and worse at these other languages. And I thought that was a really good insight and a really good example, kind of in a nutshell, of what a lot of what Adrian was talking about. But bringing it back to secure code, this is talking about C, C++, memory safety, etc. And it talks about a couple interesting concepts about what does it mean for code to be secure. And one of the first ones is actually secure by default, which you mentioned. And here, secure by default pretty much repeats what you just said. Make it harder to do the dumb thing, or make it harder to do the insecure thing, and make it more obvious. So I'm not sure if there's anything you want to expand on that one, or if there's some other parts of this article that really spoke to you, John, about what secure code looks like.
Yeah, I thought this is a really good article. From the point of, we either out of habit or our own ways and means, we tend to look at the security of a language, Rust or C++, whatever else. I think we too quickly dive in and start like nerding out on pointer math or stuff like that, broad example. Whereas this is more sort of, it keeps at a higher level thinking about the more humanistic aspects of it. There was a paragraph in here I like them if I can find it really quickly. It was decision density, right? Yeah. And it's just like, that's a really great phrase, but sort of the concept of how frequently does a developer have to deal with patterns, and what is that a default for them, or are they having to think about it? And really a lot of this paper is like, how much do you have to think to write, or how much do you have to think to write a software program in a particular language? And then how much do you have to think, how much do you have to use those neurons I keep talking about to be able to actually parse and understand and go, is there a problem here? Like, it's just the example I used with the Qualys guys that like did the code review and they found that the free error, but they didn't realize it was a double free. And this is like, pretty hardcore guys doing this, and they're still not catching every single thing at the first time. So I thought that aspect of it was really great. Disclosure. I like Perl, or I used to like Perl. But like a lot of people, just saying that word is going to really just sort of, get people all wound up. And like Perl, you can do really ugly, nasty, horrible code, but you don't have to. And that's why I liked it, because I'd like the readable version of it. But like, I think just the ability that you could do that really sort of irked folks. And that'd be, again, sorry for those I've just triggered, but that's sort of a good example of what this article is trying to get across, I think, is not allowing that maybe, and then bring that back to our C++ discussion. Is it good enough to make good enough changes on that language, or do they really need to, commit and go deep?
Yeah, and I appreciate you bringing up Perl, because I think I'm in this similar boat. And, my comment is usually, the obfuscated Perl contest is redundant. But it is fun to play code golf and understand the intricacies of a language and what it can do. There's obfuscated C, for example, that you can do strange things about the language. But what this article also points out, in addition to that density that you're talking about, is legibility and readability. How easily can someone else understand the code that you wrote? Which I think possibly ties into your stance and your philosophy behind Git messages, Git commit messages. What should you be explaining? What should the code comments explain so that you can help someone else understand why the code is written this way? And for me, another common thing that I'll just go to is that I'll just make the statement, perhaps it has a base of myth. I don't know. We'll have to check with Adrian, that readable code is more secure code. I don't necessarily have anything other than anecdotes and arguments to support that, but it ties in for me, legibility being important about secure code.
And we're sort of going down a path, and we'll move on in a second, but there was something in the last few months, I can't remember if it was something we covered on air or just something I saw in passing, but talking about the difference between a junior developer versus a senior developer. And it really did come down to, writing software is easy, quote unquote, right? Writing software which is readable, scalable, understandable, and like someone able to quickly come in and jump into it, that's what takes sort of the more mature person, or else where you start thinking about an architect title. And there's something in the back of my head sort of floating around thinking as we talk through this, how do the codeless applications sort of bring into this? Is by removing the requirement to write that code or write less code, that should help improve the security? I'm not sure we've actually have enough examples yet to really see that. At least I haven't. That'd be sort of interesting to try and track down, or maybe find some stats on.
Yeah, the article does start to talk about like how TypeScript is possibly getting there for sort of what you were alluding to, in the sense of we have JavaScript, a lot of loosely typed consequences and things that can happen, as well as the size of the software project. So maybe there is something for us to think about more with TypeScript, JavaScript, and look how much is being used. But listeners, let us know what you think about this, or if you have some other favorite languages. For example, we both of us mentioned Perl. This article mentions Lisp in parentheses. And I learned OCaml for over 1 year. And man, it was really fun and neat. But wow, did I get sick of trying to count parentheses and balancing them. So the other thing, speaking of balancing, we can't just talk about secure coding, because we have to talk about how code is put together and what kind of bills of materials can come into them. And John, you may not realize this, but there are not only S-bombs, but there are P-bombs, which sounds naughty, but it is not, so bear with us. I pulled an article that is about, from MITRE, talking about another framework for talking about software supply chain attacks, and this is OSC&R. And I just closed my tab to tell you what OSC&R stands for. But it was sort of like, I appreciate the nomenclature. So we can talk about problems. We can say, this is how supply chains are attacked. This is where they're attacked. So we can talk about threat models and say, is this control working? So Salsa is my software built with integrity, built securely. And OSC&R, this new framework from MITRE, is more about, is what attacks were considered, or is the S-bomb telling us, whether how much we can trust that is taken into account different types of attacks. And I have to go back and check my notes. So save me here, John.
Yeah.
What are your reactions?
OSC&R is the Open Software Supply Chain Attack Reference.
Thank you.
Yeah, it looks really neat. This is my first time. It was before we were going to record this. Was the first time I actually saw this, and our producer and Mike were like, "Are you okay?" And I'm like, I just had this look on my face as I was looking at this. It looks quite impressive. So yeah, I'm trying to sort of summarize it for folks in a. I mean, if we've seen that the matrix, we're getting used now to these matrices around. We've got the attack matrix. We've got there's some other ones out there. OWASP has some. There's maturity matrices. So this is one now from a pipeline point of view. It is it's a lot to take in a small sort of sitting. I think you can. I'm guessing. Can I? Oh, I can't click through here. Or at least maybe my JavaScript is off. No, it's pbomb.dev, by the way, for our listeners. Yeah, my sense is if once I spend 10, 15 minutes sort of looking at it, it's going to sort of I'll embrace and be able to. I like what it's doing, but it feels like I'm being hit with a lot of stuff really quickly, and that talks to the complexity of these pipelines, which I think have been really. We haven't focused on. I mean, I've mentioned it once, twice over the last year or two, I think, but it requires a lot more of our effort, I think. We're just talking about readability and those type of concepts. I mean, I don't know. Very seldom do I see a workflow diagram of an organization's CI pipeline. It's a fairly complex beast in many cases. So, yeah, I don't know. It's a good find.
Yeah, and be interesting to see just that aspect of the ecosystem around building software. And can we trust the software? Is the software secure regardless of the language? Was it built securely? Was it built without flaws? Which is something that who knows if that's attainable. But there's also a way of thinking of this. Does the PBOM, the pipeline bill of materials, or the software bill of materials, it's not. There's a frame. There can be potentially a framing issue here, and here I'm tying it back to our discussion with Adrian in the sense of, well, SBOMs will fix this. If we just say that phrase, we're kind of being a little too vague if we say what this is. SBOMs aren't out here to save us, and they're not going to fix software just because we have the bill of materials. And I think you have an article that's kind of speaking to that in the sense of SBOMs maybe have a place, maybe they don't, but we should probably be more accurate on what that place is.
Yeah, so this is written by Chris Romeo, who's been on the podcast here before in the past. And it's 6 misconceptions around SBOMs. So it's a, relatively quick read. There's only 6 of them. But false sense of security, I'm not going to read all of them because I want you to read the article. It's basically, in a nutshell, I think their second point is really what it comes down to. Is an SBOM, I think we're quickly heading towards it being a checkbox compliance item. And I think there's really great value in them. And we've talked about them a lot over the last year. I think I've sort of tried to talk against them once, twice. But the concept of I love the idea of what's there. But then, okay, is the SBOM accurate? Is it up to date? What does it mean? I mean, one of my favorite tricks, I mentioned this on LinkedIn last week. One of my favorite tricks for the last month or two when people start talking about SBOMs is I'll show them a screenshot of one off of GitHub or off of Google image search. I'm like, this is what an SBOM is. And they're like, oh, what do I do with that? It's like, yeah, good luck. And yeah, right. It's like we don't talk about source files of ooh, did you see the C++ source file? It's just it's another thing. And I think the results of what we do with them and where it goes with it, that can be good and great if how you use it and how you update and all those type of things. So this is sort of an article looking at from that point of view. And my senses were, at least my bubble in the industry is starting to put the brakes a little bit on the SBOM thing. We know they're important, but it's not like, oh my God, must have the SBOM. It's like, okay, well, what's our process? Where are we doing? Where are we going with this thing? So I'm happy to see it return to that sort of method of thinking.
Yeah, I'm going to use that to pull in. I'd skipped over the other vulnerability article from F5 and talked about the OpenSSH instead. But I'm going to pull in the F5 one because there's an aspect there that it run there. So there was an authenticated format string vulnerability. One format string vuln. That sounds like a case for LLVM, for compilers to go and find that type of insecure code. So why wasn't that there? It was also running as root. So that's something also that is, I don't know that exactly that's an artifact, an attribute that goes into SBOMs, but it's one of those areas that running as root that's ancient. That's ancient days of software development. And the last thing too was also it's a SOAP interface, which I haven't myself seen a SOAP interface in ages. But I'm not sure where I was going with that, other than just talking about like where in this case would SBOM apply or not apply, and maybe I'll expand that sheet a little bit and say we also saw in 2021, I think 2020, around a couple of VPN endpoints being popped that with buffer overflows that weren't even running ASLR. And so there's like, what are you doing? That at least should go into an SBOM to say how something was compiled. So there's a couple things that can help us get there, but it's definitely not the magic wand that we can hope for.
You said a bunch of great things there really quickly. Think about, so let's see if I can... We'll see if I keep track of all of them. But the first one, well, let's start at the beginning. That question around where do we track if an application is running as root? I mean, okay, do we need something other than an SBOM? I mean, I guess you could say in theory IAC should take care of that. But that's not really, that's sort of a standard. But okay, as a part of the pipeline thing, maybe you could go back to the PBOM. But then that one at the end of like the compiler flags, like where do we keep track of that? And those are sort of mind-blowing by themselves, particularly the last one, right? I mean, you could have whatever you want to SBOM, but like if someone's done a bunch of funky things with the compiler settings, everything goes out, not quite everything goes out the window. It's not the end of the world, but that's, it's just another sort of corner of the room with there's no light on it. And I think it's, I don't know. I suspect you got me thinking about it now. I suspect we'll have to see some sort of like meta bomb. Maybe I should just go register that URL right now. But our domain, we're going to see some sort of thing has to be higher level to be able to keep track of some of this stuff. So we're not there yet, folks.
Yeah, our ABOM, our application bill of materials, and then we need I don't know. We'll just go create a Git bomb.
We need to do this right and contact the marketing folks. ASW bomb.
There we go. Let's see. You mentioned tool of the week. That was GPT commit. And we were talking about that in broader things. Anything else you wanted to touch on that? Because I've got a tool of my own that I can mention too this week.
No, I think that's excuse me. I think that's sort of I only use one tool every week, and that was a tool for last week. No, it's I think. As it's interesting. Well, being me is interesting, right? Because I'm able to bounce around from security to software development to 3D printing to all these sort of different areas. So depending on what I'm working on in a given week, what that tool is going to be miles different. On the code stuff, I haven't really started to talk. It'll probably be my tool for the next week or two, so I won't talk about it too much. Cool. But it involves Rust and ESP32, and I'll leave it at that. That's my other tool.
Ah, fun. Well, you have an article that I'm going to, one final one that kind of relates to the tool that I've got for this week, Netcat on steroids, SOCAT. But tell us about this Go module and how it was working with some proxies.
This is interesting. And it's sort of, the reason I brought this in here is to sort of talk through from the point of view of these tools we use is again, and this is sort of where SBOMs came from, but this whole concept of importing software into your application, or say, one line for you, like import a Go module, and when you go to build that or do to get the source, your tools go off and talk to other things out there on the internet, and things just magically happen. So in the Go world, Google has a proxy for a lot of them, usually for popular modules, but sometimes for less popular is what this article is showing. And you go get X, and it talks to the proxy, and then the idea is it's supposed to be like a proxy cache, caching proxy. But in this particular case, there's an open source version of GitHub out there called SourceHut. That one of the projects on there was a module which had become sort of popular in Go, and Google, for whatever reason, it looked like it was a bug, was hitting that particular Git repo hard enough that it was creating gigabytes worth of disk usage, of network traffic per day, to the degree where it's actually causing enough of a network transfer bill that it had a chance of putting the company out of business. So it took them a while to actually get them to track this down and fix it because like they'd never thought about that before, and it wasn't paying attention to robots.txt because maybe it shouldn't be paying it. It's not a crawler always, right? Sometimes it is, sometimes it's not. It was sort of these weird categories and weird sort of edge cases around it. But at the end of the day, the point being, what we do, and it seems like very simple to add a module to our software, go get some module, can have pretty big repercussions somewhere else down the line, and how do we deal with that? So it's it's a bug, it's fixed, but it's good to sort of think about how these things work.
No, it's almost like we need an ecosystem bill of materials to figure out how all these interact with each other. And that, talking about proxies and network traffic, my tool of the week was SoCat. And it's kind of like a netcat on steroids. And it's essentially a way to proxy traffic. It can do, as a README says, bidirectional data transfer between two independent data channels, which is just a really fancy way, honestly, of saying it can handle TCP, IP, UDP, TLS. It can handle IPv4, and if there's anybody using it, IPv6 even for those networks. But it's really cool, very flexible, often used it can be useful in reverse shell type of tunneling or just network debugging as well. So it has that pen testing as well as development side on it. And that was my tool of the week. And I think this means we're going to have to come to a close, Mr. Kinsella. And we missed you last week, so I just wanted to say it's good to have you here. And would you like to send our listeners off with any parting words?
It's good to be back. For those who haven't heard, I got COVID again last week for second time. It's no more fun than the first time, but happy to be back. Your SoCat article was making me think. I had a friend recently ask me, we could turn this into a listener question down the road, but we won't. What's the difference between a VPN and a tunnel? And I'll leave thinking about that as an answer or a homework assignment for our listeners. But let's keep doing the good thing and see if we can get these things more secure. How about that? Everything more secure by next week.
By next week, there we go.
Need a deadline.
Start the countdown. Thank you, John, for that. Thanks, everyone, for joining us. Please do subscribe. Hit that like button. Check out the show notes. And speaking of ASCII and the arts, check out the album Masterpiece by Celerect LA Dreams. We'll see you next week on Application Security Weekly.